Hi, for today's teardown, the last part of the Nokia Flexi base station thing, the actual main unit itself. So, very big and very heavy. This thing is a big heatsink in very thick aluminium, 10 kilos or something like this. So we have a whole bunch of plugs on the front. The DC in input here is covered by a cap because in this case the DC was coming from the distribution box here on the top. There is apparently provision for a second DC input here with the same kind of connector and watertight cap. Apart from this, we have all the plugs on the status LEDs. Here HDMI plugs, but they are not for HDMI signal, obviously, something else. And covered with those super sturdy caps. So they're called RF and extensions for the actual radio transceivers of a cell phone station. SRIO, BB extension for the extender units I did show in the previous teardown, which were connected by this cable, like such. Okay, and configuration RG45 port apparently, or communication port, so optical inputs but with HDMI connector, so probably we will have a plugin that will convert this to optical. Status LEDs on the front, main status, fan status, because on this connector here we add the two fans from the main rack unit. Okay, bottom side, more heatsinking and a whole bunch of screws to undo. So it is called the Nokia Multiradio 10 base station, and this one is made in Hungary, as it is written here, and it is called the FSMF core. Okay, so time to take it apart. We can expect a whole bunch of processing power in this, a lot of silicon chips. Even if I will not be able to tell exactly what is doing what, but still it should be pretty interesting to look at. My plan is to keep the circuit boards inside, but sell the metal to a scrapyard because it is really too heavy. I have no space for such stuff, sadly, and I will refund my purchase just by selling the metal, I believe. And as you will see, we have two circuit boards inside, so they will be a lot easier to store than a big flag box like this. Okay, first I will undo this cover here. So first this DC input will just cover. As you can see, we have two big screw terminals in tinned copper or brass. With super long screws, like such, and the two terminals will come off here. They are super nice, but they will probably go to the scrapyard because I have no use for such big stuff. Okay, 2 more covers here to undo. Okay, I see big bus bars here. There is plus and minus engraved here in the plastic directly. And I see a quite nice little piece of brass again here. I will try to salvage it. Okay, apart from this, there is nothing else to undo. There is some kind of cap here with a little hole at the bottom. So I will keep this thing, it can be useful, but I have no idea what it was used for. You can see a little hole, okay, and here you can see the opening for the slot in connector, which is still here in my box of hard drive from this teardown project. So it will go in here like such, and same one here. Okay, it will fit also in the other slot. Nice. I think it is time to turn it upside down. And just undo a few screws. I think we are good. The cover should lift quite easily because I did already undo it one time. Okay, the same kind of seal we had in the other unit. This one is still in place, and you can see this lid part is actually written, where is it? Made in China. Okay. Aluminium with silicium, made in 2016 apparently. Okay, good piece for the scrapyard. We have extra seals here for RF insulation, because in here we have two large circuit boards mounted upside down with silver coated tracks, no gold coating here. Okay, time to install the camera overhead, I believe. So, before I undo the screws, general look, we can see we have two circuit boards secured by a number of tiny Torx screws, of course. Not easy to tell what we have. A whole bunch of decoupling capacitors here, super tiny ones, you can see. So probably behind each one of those capacitors islands we have a big IC chip. Here the fans connector arriving here with a whole more decoupling caps. These connectors are a little bit like the ones you find in cars. So this one is pretty much damaged, but this one is almost good, even if I do not plan to reuse them. So you can see there is a seal, and they will go like such, more or less, but they are not really terribly good, these things. And there is a cable gland here and two more connectors, so all this will be scrapped. The two boards are connected together with two high density connectors you can see here. And same deal here. In this area, a whole bunch of inductors apparently and big resistors, maybe to measure some current. Here we have the power input side with two big unknown protection devices. Do not mind the different screws here. When I took apart this thing the first time, I stripped a torque screw and then I prefer to replace with something else, even if it was pretty much pointless, because anyways I did not power this thing and I do not plan to power it on. The only thing that could happen is to have some lights turning on, so not really interesting. I do not have the software or cables or anything else to try to extract the data, as is, for instance, configuration data from it or something like this. So time to take it apart. Interesting thing here on this plug here, you can see there is a little hole and it will go to some kind of switch, maybe a reset switch. Okay, so time to undo a million screws and I will be right back. Okay, I think it is good. As you can see, this thing is too large to fit on my camera frame and is reflecting a lot my overhead LED light I made almost 10 years ago, and this thing is still holding strong and working perfectly, made from a cheap Chinese LED strip and some scrap metal. And really quite happy with this work. Even if it is not beautiful, it is doing the job. And really maybe I could add some diffusing plastic over the LEDs to avoid such kind of reflections with bright stuff, but still okay. We are good. So the thing is, you have to lift all the boards at once. So this one will come off, will flip out of the way, and then I can undo the two connectors to the fans cables. Okay, so first one is out. A lot of cleaning work to do here. Pretty impressive connectors here, by the way. And the second one will be the same deal. You can see the nice pattern here in the heat sinking grease. Really, definitely some nice robot work here. It will need cleaning before I put it to the scrapyard. Will be fun. So the overboard should just come off like such. This one is a lot cleaner, just one IC to clean. And in the main part we have nothing left except the DC input thing. I have no idea of how it will come off. I do not see any screw on it. Maybe it will just press fit. Let me just try to free it. There is a seal, I can see. So it will need some figuring out, I believe. Maybe there is a hidden screw somewhere or something. Or it is just glued. I will see, but this might be tin copper. Maybe some hammer work. Well, I will see. And here just springy metal things to ground the board with light pipes to the status LEDs on the top. And of course more heatsink grease everywhere. Blue. Okay. It will be really fun to clean all this. Made in China, also in really. The decode of this one is 2015. So it looks like they will keep the same mechanical shape along, or maybe they will just modify upgrade the circuit boards. So there is the two annoying pins to the on the top that are protruding, but maybe I will be able to hammer them out here as they are poking out from the other side. They are not magnetic, so I could sell the metal to the scrapyard as is, but I prefer to clean my stuff, and I will try anyways to drive them out, maybe by first heating the area to expand a little bit the aluminium. I will see. And this time we have aluminium, silicium, magnesium compound. Okay, nice mixed. It will be a good scrap yard item. Okay, let me put this out of the way for now. So I will clean those boards and I will be right back. Okay, it is better. So considering I have no precise idea of what all this stuff is doing, we will just have a close-up look at the parts. We will start with the power input side, I believe. Where is it? Power input? No, excuse me, it is the other one actually. Okay, so the two terminals to the external power supply. Big again protection devices. We have the same ones on the back. It is not really written what it is, and there is not a lot of screen on this board. You can see there is no the number of each one of the part, or maybe it is under the parts. This one, blue, probably anti-surge protection. Big ceramic surface mount fuses here and here, a lot of them. This one is has gold legs, coils here, a whole bunch of capacitors, and those interesting flat profile transformers. Quite nice. So it is really a very compact design of a local power supply. Connectors here to the overboard, you can see high density connectors like in supercomputers. Really nice. The boards, you can see, are already pretty thick, at least 2 millimeters. Very nice edge also on them. So we continue with all the inputs on the SFP connectors. up to here the vertically mounted HDMI kind plugs, quite unusual, you can see. More stuff here, what seems to be network filters, isolation filters here, like in Ethernet switches. Here a little plastic cover which is covering what seems to be the main crystal oscillator, 30.72 MHz. Surface mount, mounted on a board, but you can see it is soldered like this. Here we have a plug-in module with memory chips. What is it written? Country of origin Singapore, real SSD. Okay, so it is a SSD drive containing probably all the configuration information, which is interesting, but I do not think this kind of connector here is something common, not sure. Maybe there is a way to find a converter and just connect it in a USB. Should be pretty nice to be able to read the contents. So comment if you have any information about which standard it is and which converter hardware I will need to get in order to be able to connect this to a PC and read the contents. Okay, then we are going to the processing stuff. We have, again, I believe we had one in the previous unit, Octeon 2 by Cavium processor, even if I did never hear about it previously. One more stuff. Mercure 2, I think we have already the same one also in the other unit. And this were the golden, well, orange, golden part here. Maybe also a crystal oscillator. Not sure. The cap on it could pry off to reveal the contents, but it is just a little board with surface mount parts inside, it seems. Or there is maybe something in the cap part itself. Okay, and all the extension connectors here, the LED for the status indicators, and fingerprints everywhere. Not mine, I believe. I am not sure, but I do not believe those are mine. With the clean off. No, they are old definitely because they do not come off easily. Okay, so the second board. Of course, we have a matching connector to the first board. Again, a local power supply unit with the same kind of flat transformers. The plugs here to the fan cable. And another Cavium Octeon 2 with his ROM or RAM here. And then a whole bunch of Texas Instruments DSPs. They are all the same. No, not exactly. We have two different models. This one ends with 6, and these ones have 8. So we have 3 of each. Another little IC here by IDT. Yes, as you can see, it is written here. We have silver in the circuit board. So not sure if all the tracks will be covered with silver, or just the ones you can see through the solder mask here, probably all the tracks. Okay, because silver is a lot less expensive than gold. Xylix Spartan 2, okay, FPGA, nice cover on this cavium thing. You can see it seems to be a 2-layer cover, interesting. And those DSPs also have a heatsink like this. These covers are usually tin plated copper. Okay, so you can see each one of those DSPs seems to have Hynix RAM chips, local coils here for maybe or no low value resistors 0 ohm 56, probably to measure the current pumped by each one of those ICs. And this one also has this, so they will be able to monitor the consumption of each one and manage the load or something like this, or detect if the one is going bad. Okay, load balancing maybe. And of course each one of those ICs has a few more auxiliary ICs at the back, and a whole bunch of super micro tiny capacitors. Those ICs here are quite weird, you can see, because the legs, with the contacts, the pads, are all around. But we have, so maybe we have a piece of a circuit board as a first layer, with making the contacts to the outside, and then a bonded IC chip, and then they did cover it with resin. Quite another one. I am not sure if there is any information written on them. It is impossible to see. Okay. And this board is written made in Hungary. So not sure about the PCB itself. Maybe it was mainly the pick and place, which was located in Hungary. Interesting. So they can go together like this. I will reconnect them just for you, for the hell of it. Okay, a massive thing. So it will be phenol connectors here. You can see I did not notice this. I will unplug them. This one is interesting because you can see the contacts are actually tracks like this in a layer of sandwich, vertically mounted pieces of plastic, with each one having the contacts like this, the tracks like this. Probably here it is not totally the same thing, it is just the same bended part here, with this cover over it, over them. Okay, so interesting stuff. I will put those two boards in bubble wrap and keep them in my storage, even if I am not sure of what I will do with them. They will be nice to take storage space for sure, but I want to keep it because it is not stuff you find easily, and all the metal will go to the scrapyard after I finish cleaning it. Okay, quite nice stuff. It was only 12 euros for the whole thing on eBay, so why not? At least now I took one apart. So thanks for watching, bye bye.